continuing along, so let's discuss reaction mechanisms. So this is only an introduction. For those of you that go on to take organic chemistry, you will spend like a whole year talking about reaction mechanisms. Some of you will love it, some of you will hate it, and that's just kind of how it goes in chemistry. So a reaction mechanism is a set of steps that describes how a reaction occurs at the molecular level. And this set of steps must be consistent with the rate law for the reaction. So if the total rate law for the reaction is second order, then the reaction mechanism has to be second order. Okay? So an elementary step is a molecular view of a single process taking place in a chemical reaction. So we could actually say that a reaction mechanism is comprised of several elementary steps. Okay? And what's also important is when we know something is an elementary step, the stoichiometry gives us the order. Okay, so let's write that down. Stoichiometry equals reaction order, but only for an elementary step. So what is often confusing in chemistry and why kinetics requires experimental study is because when you look at an overall reaction, you don't necessarily know if that's just one elementary step or if that's the total reaction mechanism, okay? And we're gonna see that flush out here in a moment. So an intermediate is a species that's produced in one step of a reaction and consumed in the subsequent second step. And then finally, molecularity is the number of ions, atoms, or molecules involved in an elementary step of reaction, and this gives us the reaction order. So for example, so here we have a bunch of elementary steps, okay? And we're saying, like, we know these are elementary steps. They're single processes taking place. So if we have just an A goes to products, we call that a unimolecular, which means first order, and the rate constant is just K times A, raised to the first power, okay? So we could think of a first order reaction as a unimolecular reaction, which means there's only one molecule involved, okay? So let's suppose our reaction gets a little more complicated and it's A plus A, or in other words, 2A goes to products. We would call that bimolecular. Of course, that's second order, and the rate constant would be K times A squared, or excuse me, the rate law would be K times A squared. Or we could also have a second order reaction in which we have an A plus a B, where it's first order in A and first order in B, giving us second order overall. Well, you can see that's two unimolecular reactants, so that would give us a bimolecular. Two molecules, A and B, collide and react. And of course, the rate law would be K times A times B, which would still be second order. Of course, if we had now a third reactant, so for example, 2A plus B, or even A plus B plus C, we just start calling that termolecular, which is another way of just saying a mini-bodied reaction. So termolecular could be third order, fourth order, fifth order, although fourth order and fifth order reactions are extraordinarily rare. Usually third order is about as high as we'll see. And of course, if we had a third order reaction, if it was 2A plus B, then it would be Ka squared times B. 2 plus 1 gives me 3. And then of course, if it was A plus B plus C, that would be Ka times A times B times C. And that would be third order because it's still first order in A, first order in B, first order in C. Okay. So let's move on and